All right, so what we're looking at today is that we're looking at the last part of our mathematics of money stuff. And so what we're going to be looking at is we're going to be looking at something called installment loans, deferred annuity, and geometric sequence. And we're going to start off with geometric sequence because it's going to be the easiest one to talk about first. All right. So the first thing that we have is that we have our geometric sequence. Now, a geometric sequence is different from an arithmetic sequence or arithmetic sequence, depending on how you want to do it. But an arithmetic sequence is a sequence that grows at a constant number that you're adding to it. Okay, so an arithmetic sequence uses addition, and so in this case we got 5, 10, 15, 20, 25. That's an addition of 5 each time. All right, and so that's what we have, is that we're going to be growing at a constant rate of 5, adding 5 each time. A geometric sequence is a little bit different. A geometric sequence, what it's doing is that it's multiplying, and it's using something called a common ratio. So a common ratio, in this case, the common ratio is 5. No, not 5. It's 2. We're multiplying each of these numbers by 2 to get it up, get it moving up. So what we have is that 10 times 2 is 20, 20 times 2 is 40, 40, and so on. And to find what the common ratio is, you'll take the second number and divide it by the number previous, 2. If they're all the same, you end up getting the common ratio, and it is some sort of geometric sequence. So in this case, it is a geometric sequence. All right? All right, now, get into the fun stuff. Deferred annuity. Now, a deferred annuity, what it is that it's something that you do to put money away to save money and get a lump sum at a later date. So you're putting money away to get more at the end of the term, whatever it is, the amount you're saving, and you're going to get the money in at the bottom or at the end. All right. So it's saving for the future. This could be a trust fund for a kid. It could be saving money for a car. It could be saving money for a retirement, saving money for a house. It could be anything like that. Anything that you're saving money for, okay? And you're just putting money away. So let's say we have this, okay, so we got 20, let's say you're 25, so, you're close to my age. And what you're going to do is you're going to start putting $200 away a month into some sort of deferred annuity account with about 5% interest. All right? Now, you're putting money away until you retire at the age of 65. Now, that's 40 years away for those of you that don't want to do that simple math, but it's just 40 years away. So if we do it 40 years, we want to keep track of how much we're going to have at the end. And we're going to use this formula down here at the bottom, which is F is equal to L, and you can read it from the bottom. But the only thing here that you're going to have to know is that L is how much you deposit each month times 1 plus the rate, or the rate for each one. Remember, this 5% is like the APY, so you're going to have to take the 5 and divide it by 12. Or 0.05 and divide it by 12, and that's what that's going to be your P. And you're going to add that in, and then the principal is the 200, how much you're adding each month. Okay, and you're going to do it for T, which is the number times the year times the years. So this would be 40 times 12. All right. Now, here it is when you plug in all the numbers. So basically, this formula is you just plug it in and you just do it. So it's a plug and chug formula. Plug everything in. Calculate it down, calculate it down, calculate it down, and we see that we end up getting $305,834.56. So at 65, they would give you that much because that's how much you saved. You don't think putting away $200 a month for 40 years would get you that much, but it does. It gets you a lot, and you'll celebrate by putting on a sweet hat and a suit and walking around going, yeah, I got the cash. Now, the other one, besides putting money away, what we have is we have an installment loan, which is where somebody gives you money in advance and you slowly pay them off. This is a car loan, house loan, business loan, college loans, all these things, banks and other businesses give you money, and then over time you're going to pay it off. Okay? And what this does is that over time, the amount that they give you builds interest, and then you have to pay it off over time. You have to pay that extra interest. So let's say you want to get a car loan. Okay, you want to buy some sort of sweet, awesome ride, fast car, probably something like this. And to buy a car like this, you would need a car loan. because that car is just way too sweet. And so let's say you get a car loan and it's about $9,000 you take out to buy that car. All right. Now, the dealer's offering you an 8% interest rate for 3 years. So you're going to be paying, you want to find out how much will your monthly payment be for 3 years at 8% when you take out $9,000. Okay. Now, the formula at the bottom of this page right here is what you're going to use. Now, this formula is a little bit different from the other ones for this problem. All right. And the reason for that is because what we have is that this finds the P, this formula finds the principal, but in this problem we're given it. So what you have to do is that you're going to have to take it and you're going to have to solve for the F to get everything. Okay. Now, if you want to do this beforehand, it would just be capital P times 1 plus lowercase p times 1 over 1 plus p minus 1 all over 1 over 1 plus lowercase p to the t minus 1. Okay, and that would give you F. And that's just using some algebra. So what's going to happen is that we're going to take this and we're going to put all those numbers in and solve it, and we're going to get it. So when you plug all those numbers in, and as you see when you plug it in, all you have to really do is you just have to start simplifying the numbers down and down and down and down and down and down and down. And you're going to end up getting a fraction with the variable is equal to 9,000. And then when you divide that through, you see that you end up getting about $282.19. So that's how much you would pay each month. All right, that's how much you'd pay each month for 3 years to pay off that loan. All right. And then when you pay it off, after those 3 years, you know what happens? You celebrate, you jump up in the air with your arms up, and like this woman, and say, yes, whatever it is that you paid for, whatever it is you took the loan out, is officially yours, and you do not own any money on it. And you are uber excited, and you're just jumping up and going, yeah! All right? So that's what this is. An installment loan pays off something that was given to you earlier, and you pay it off over time. So let's review here. Think. A geometric sequence. A geometric sequence is a sequence that uses some sort of common ratio. Okay. So our common ratio, again, is being multiplied into it. It could be a whole number, it could be a fraction, it could be positive, it could be negative. Okay, we're just multiplying something into it. All right, a deferred annuity is something that's an equal payment over time, and then at the end you're going to get a lump sum back of everything. So it's saving money over time. And the last one was an installment loan. That's where you're given money ahead of time, and then you slowly pay it off over time. So an installment loan is more for debt, and an annuity is more for saving. Okay, so that's the difference between them. Okay, annuities for saving, loans are for debts. Okay, and we're going to be doing some of these in class. So yeah.